Hello guys, and welcome to the Data Structures in Python full course. In this video, we'll talk about the definitions of data structures and the types which are the built-in and the user-defined data structures, and we will focus on the built-in data structures, which are lists, tuples, sets, and dictionaries. Data structure is a way of collecting, organizing, and storing data in a way that we can access and perform operations on this data efficiently. As we are dealing with data science, data analysis, big data, data has to be organized and it has to be in specific memories locations and in specific, for example, lists, dictionaries, sets, depending on your programs and depending on the tasks and the problems that you are resolving. This data needs to have a form that allows you to understand it rapidly and to work with it efficiently. We have two types of data structures in Python. We have the inbuilt data structures, which are built inside our programs and in Python. And we have also the user-defined data structures. Data structures that you are going to define in your program and you are going to implement these functions or classes depending on your problems. For the inbuilt, we have lists, tuples, dictionaries, and sets. User-defined data structures, we have tree, graph, stack, linked list, and queue. Inbuilt data structures can be mutable or immutable. Mutable means that you can modify it. You can add, you can insert, you can remove, you can delete, depending on what you are looking for and what are using these data structures for. For the mutable, we have lists, dictionaries, and sets. Immutable data structures means that they cannot be modified. And we have only one type, which is called tuples. A list is defined as an ordered collection of items. It is the most used among Python data structures. It is changeable, which means that we can add, we can remove, and we can modify it during our programming task. It allows duplicates, and lists can be nested, which means that we can have a list inside another list. Okay, so the items inside a list can be also lists. A tuple is defined as an ordered collection of items, as a list, but it cannot be modified. Once you define a tuple, it will stay as it is in all your process of programming. And tuples are preferred over the lists when the user does not want the data to be modified. Dictionaries are used to store data values in key, comma, value pairs. It is a collection which is ordered and they are changeable, but they do not allow duplicates. As we have said, lists allow duplicates in your program, but it is not the case for the dictionaries. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that inside a set, for example, we cannot find two elements that are the same. For example, in a list, you can have, for example, the element number 1 is letter E, the second is letter E, the third one is letter E. but inside a set you can only have one letter. For example, E or I or T. So sets allow you to have unique elements, which means that you cannot have a lot of elements that are the same. For the user-defined data structures, we start by a linked list, which is a linear structure that is represented by a collection of nodes, and each node is linked to the other node by using a pointer. Linked lists are built in Python using classes. So object-oriented programming will allow you to build this kind of data structures, which is very powerful in very specific cases. A stack is also a linear structure that allows data to be inserted and removed from the same end. As you can see from this image, the last element that is added to the list is the first element that is going to be out, which means that last in, first out. We have also the queue, which is a linear structure as a stack, but the only difference here is that the first element that gets in is the first element that gets out. Okay, so it allows insertion of elements from one end and deletion from the other end. We have also trees, which are very useful and are applied in, for example, machine learning. You can apply binary trees in a lot of examples using classes and object-oriented programming. A tree is a nonlinear but a hierarchical data structure. The topmost node is known as a root node. Each node contains some data, and data can be of any type. Finally, we have the graph. A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them. A list is defined as an ordered collection of items, which means that each item has its own index, and it can be called or accessed using these indices. As I said, it is the most used among Python data structures. It is changeable, which means that we can add, we can delete or remove items from the list. It allows duplicates, which means that we can have more than one word or one number in the list. And also lists can be nested, which means that we can have the items inside the list as lists. To start, we can create an empty list. For example, we can start by my list equals to, and you add square brackets like that. So when you want to know the type of your data, you can just write type and it gives you lists. You can have here node. We cannot use the keyword list as the name of the list. Okay, we cannot use, for example, here list equals to this empty list, for example, because it will generate an error. You can also create an empty list using directly my list, we call it 2 equals to list, the function, the built-in function list. Okay, so when you print my list 2, it will give you an empty list. As we have said here, list cannot be used as the name of the list because we can use it to create another list. Here we have the function, and also to create not only an empty function, but we can have some items in our list. For example, my list 3 equals to, you can write list, you have here the parentheses, and you also add another parentheses. Okay, inside the list we can have different data types. Okay, so you can write a comment here, we can have different data types inside list. For example, we can have string, okay, 1, we can have an integer 2, we can have float 0.5, we can have a boolean true, for example, or false. We can have also another list, for example, this, for example, is a list, for example, okay, etc. So if you're gonna run that, you have type of my list 3, it is a list, okay. And here in Jupyter Notebook, you don't need to write, for example, print my list 3, okay. You can directly have my list 3 like that, and it will print it to you. Okay, so we have the different data types inside our list. As we have said, we can have the item as another list. You can have boolean, you can have float, integer, you can have string, etc. To know the length of your list, you use the function len. So len my list 3 will give you 6. So 1, 2, 3, 4, 5, and the whole list is considered as one item. Okay. If you want to know the length of the empty list, for example, my list 2, you have 0 because it is an empty list. An important thing to do before starting modifying or working with your list is to create a copy. So you can write list copy, for example, okay, equals to my list 3 dot copy. Okay, so if you are going to print that, you have your function. Sorry, we use the function, so you have to add the parentheses. You use the copy function to copy your list if you want to modify it in your program, because if you are going to modify this list directly, it will change directly the memory location of your data. So for example, if you want to change 1 to 2, it will directly change it from your list. But here, since you have a copy, you can work with your copy, you can add, you can remove, you can do all what you want in this list. But if you want to call the first one, you will have it unchanged. Okay, so this is a very important thing to do if you want to work with your list in your program. To access your elements, for example, the element number, first element, you start from 0. Okay, you start from 0. So this is indexing, right? Call this indexing. Sorry. Call this indexing, right? If you want to, for example, access the last element, so this list, we can use list copy, for example, -1. Okay, so -1, gives you the last element. So 0 gives you the first element. So 0 gives you the first element of the list, and -1 gives you the last element of the list. Okay, so just copy that. We have here -1 gives you the last element of your list. Okay, and if you want to access, for example, from 1 to false, you can directly start from 0, 1, 2, 3, 4. Okay, so you write list from 0 to 5. Sorry, list copy. I'm sorry, it is not defined. Opa. List copy, right? So as I said, from 0, 1, 2, 3, 4. I have written here 5 because it accesses the element 5 minus 1. Okay, so it starts from 0 to 5 minus 1, which means that to 4. So 0, 1, 2, 3, 4. Okay, and for example, if you want to access 1, then 3.5, then false, you can use here list copy, and you increment by 2. Okay, so you increment by 2, so 1, 3.5, and false. Okay, this is slicing, we call this slicing, and here we increment by 2. We increment by 2. Okay, so this is about slicing and dicing and incrementing by different value that you want. So you start from, this is the start, this is the end, so we'll access the element, this element -1, and here the value that you want to increment. For example, you want to increment by 2, by 1. As you can see here, by default it is 1. Okay, so this is about accessing your elements inside the list. For example, if we want to loop over the list, for example, to know the elements of the list, we can use the for loop for element in what is called list copy. Okay, list copy. So print element, print. So it will print for you the elements line by line. So this is for looping through a list, for example. Okay, so we use the for loop to access the element of our list. Sorry. And if you want to change, for example, the first element or the second element, so we have list copy, right? List copy. We have 2 equals 2. For example, we change it to string. Okay, right. And if you are going to implement that or to print that, you will have 1, 2, okay, 3, 4, 5. Okay, if you want to change it, for example, from 2, so from this one so 0, 1, 2, 3, 4. So we write from 2 to 5, for example, list copy, for example, from 2 to 5 equals 2. For example, we write 3, 4, 5, 3, 4, and 5, for example. Okay, and if we print that list copy, so you will have the values changed. Okay, 1, 2, 3, 4, 5. So this is about changing the elements of your list. For example, if we want to remove this element, so we can write list copy, okay, dot pop, and we have the index number 5. Right, so it has removed this list for us. If we check, we find that the list, it does not exist anymore in our list. Okay, so this is to remove an item, to remove an item using index. Okay, so using index, we can do it also by using the del function. So del list copy. Okay, and we want to remove the fourth element, for example, so 0 1 2 3 4. Right, so list copy, and we have only the 4 elements, 1 2 3 4. Okay, we can also remove using we can also remove using the remove function. So you have this list copy dot remove, for example, we say 3. Okay, run list copy, and we have 1 2 4. Okay, so we have 3 is removed and 5 also is removed. So here we remove using the name of the item. Okay, here by the index, here by the index, and here by using directly the name of your element or your item. If you want, for example, to add elements, so here we have removing, and here we will add. So add elements using the append function. So list copy dot append, and you write the word of, for example, that you want to add. So here we have removed 5, we will add 5. Okay, right. If we copy that fast, we have 1 2 4 5. We have removed the number 3, which is in the position 0 1 2. To add the 3 in its position, I mean in its first position, we can use the insert function. So we write list copy dot insert, and we set that position number 2, and the value is 3. Okay, so if we're gonna run that, we'll have 1 2 3 4 5. Okay, and also if we want to add more than one element to our list, for example, we have add list equals to, for example, 6 and 7, we can use the extend function. So you have list copy dot extend, and you put add list. Okay, so if you are going to print that list copy, we will have the elements added. So we have 1 2 3 4 5 6 and 7. And we can also, so here we add more than one element. So here we have add an element by index and now here we add element automatically to the end of the list. Okay, and we can also sort our list. So list copy dot sort. So if you're gonna put that, for example, list copy equals to. If you want to print that, it will order it depending on the letters. Okay, so we have F, O, S, T, and T. All right. And finally, if you want to delete your entire list, you can use del and list copy, and this will directly delete the entire list for you. Or you can, if you want to clear it, you can use this. So list copy dot clear, and this will return to you list copy with no items, which means that it will be an empty list. Tuples support all the data types as items, which means that we can have strings, can have integers, can have boolean, etc. Tuples, they cannot modify it. As we have seen for lists, they are changeable and they can be modified. So in a list, we can add, we can remove, we can extend the list, etc. But this is not the case for the tuples. So tuples are preferred over the lists when the user does not want the data to be modified. To create a tuple, we use the parentheses. So we call it tuple 1 equals to, you open the parentheses and you write, for example, 1, 2, and 3, for example. Okay, so we have here a tuple that contains items as strings. To know which data type tuple 1, and you get a tuple. To know the length of the tuple, it is the same as lists. We use the len function. So len tuple 1, and it gives you number 3. To access the first element of your tuple, we write tuple 1 square brackets 0, and we run that. If you want to access the last element, you write -1. Sorry, tuple 1. So here we access the last element of our tuple. So this one is called indexing. This one also is reverse indexing. And we have also slicing. So if you want to access, for example, the first 2 elements, you can write tuple 1 and you start from 0 to 2. Okay, so this is about creating a tuple, the type function, the length function, indexing, and slicing. So as we have said, tuples are unchangeable, which means that they cannot modify it. For example, if you want to modify the first element, tuple 0, and you can change it, for example, to 0, says that tuple object that does not support item assignment. One method to do that is to convert your tuple to a list. So tuple converted equals to list tuple 1, run, and here, for example, you can change this one. So we write tuple converted. Okay, we have 0, which is equals to 0, right? And we are going to modify this one into our tuple. Okay, tuple using the tuple function. So this is converting a tuple into a list. So converting tuple into a list. Then we add our elements and converting the list to a tuple. Okay, so here converting a list into a tuple. All right. So this is one way. If you want to modify, for example, your tuple during your program assignment, so you can just convert the tuple to a list, modify it, then convert the tuple into the list into a tuple again. So as we have said, tuples as lists, they allow duplicates. For example, we can create tuple 2, right? We write for example 1 1 1, for example 3 4, etc. So here we have 3 ones. Okay, if we run that, we will get no error because tuples allow duplicates. So we have here tuples allow duplicates. Okay, duplicates, sorry. So we have they allow duplicates, and also we can access the elements of our tuple using the for loop. Okay, so for element, okay, in tuple 2, okay, print element. So it will print for us all the elements inside the tuple line by line. And also, as we have said, tuples support different data types. So if we create tuple 3 equals to, for example, today, okay, and here we have 1, here we have 3.45, here we have false, and we can have also another tuple inside. So 1, 2, 3, and 4. Okay, run. So tuple 3 will give us these different elements. So we can have a tuple inside a tuple. Can also have a list inside a tuple, which means that tuples allow different data types. Okay, so tuples allow different data types. Okay, one way also for creating tuples is using the tuple function, as we have said earlier, but here we use the double parentheses. So we create parentheses first time and another time. Okay, so we create 2 again 1, for example. Okay, 2 again 1. Okay, so we create that, we call it tuple number 4. Okay, so tuple 4, we have its type, it is a tuple. Okay, so write type will get a tuple. Okay, but if we only use one parenthesis, okay, so tuple expected at most one argument got 3. Okay, so it will generate for us an error. So here we have double parentheses. Just be careful about that when you want to create tuple directly using the tuple function. Okay, and if you want to print that tuple 4. Also, if you want to create a one element tuple, so call it tuple 5, we write parentheses like that, and we create, for example, element, we call it element, and we have to add a comma. Okay, run. So if you write type tuple 5, we'll get a tuple. But if we remove the comma, okay, it is a string. Okay, so be careful about that. If you want to create one element tuple, you have to add the comma. Okay, tuple. You can also create another tuple, call it tuple 6, which is equals to, for example, tuple 3, for example, plus tuple 5. Okay, tuple 3, okay, plus tuple 5. Okay, so this is about joining tuples. Okay, this is joining or adding tuples. Okay, and the one function that we use when we are dealing with tuples, for example, if you have tuple 7, okay, equals to, for example, 1 2 3 2 3 4, sorry, 4, for example, 5 9 10 7 3, for example. Okay, so this is tuple 7. If you want to count the number of, for example, of 2's or of 3's in your tuple, you can use the count function. So we write tuple 7 dot count, for example, 2. So we have 2's in our tuple. For example, if we write tuple 7 dot count 3, it will give you 3. So we have 1, 2, and 3. So we have 3 3's. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that we don't use indices as lists and tuples in sets. It is iterable, which means that we can use a loop to print our elements inside the set. It is mutable, which means that we can add, we can remove, and has no duplicates elements. So it does not allow to have duplicates inside itself. Sets are highly useful to efficiently remove duplicate values from a collection like a list. As we have seen, in a list, you can have duplicates or more than 2 elements inside a list. So to know the unique elements of this sequence, we can use a set and convert it. Thus, we will get out of the duplicates. Sets also are useful to perform common math operations like unions and intersections. To create a set, we use the curly brackets. So we call, for example, set1 equals to, for example, we get a set of numbers. So 1, 2, for example, 3. Okay? Use type function to know the type of your data structure. So it gives you a set. We use the len to find the length of the set, which is 3. Set 1 0. Set object is not subscriptable. Okay, so as we have said, we don't have index for this element or this one or that element. Okay, also it is unchangeable, which means that, for example, if you want to change this element to, I don't know, for example, we call it 4, we cannot do that. Okay, because this set do not support item assignment. Okay, and also if you want to create an empty set, we cannot use directly the curly brackets as we do for the list. For example, we use directly the square brackets, or in tuples we use the parentheses, but here if we use directly the curly brackets, we get the type as a dictionary. Okay, so if you want to create an empty set, you use directly the set function. Okay, so write set, and here we have the type, which is a set. Okay, and the length, which is an empty set, so it will give us 0 as the length. Okay, so this is about creating sets. We said that they are unordered, which means that we don't have indices, and also we use the type and the length function as lists and sets and tuples, sorry. So for example, if you want to create a list, sorry, we cannot use the keyword list1 equals to, for example, 1 2 3 1 1 1 1 3 4 5, for example. Okay, and you want to know the number of unique elements inside this list, so we can use this set list equals to set list1. Okay, so if we want to print the unique elements of this list, we will get directly 1 2 3 4 and 5, so it will get out of the duplicates. Okay, so this is one way to know the number of unique or the unique elements inside the sequence. So we are going to copy that, for example, set1. Okay, and we want to loop through this set. So for I in set1, we print the I 1 2 3. So as tuples and lists, we can use the for loop to iterate through the sequence or over the sequence and print our elements. So as we have said, we can have any data type if we want that we want inside set. So we have, for example, 1 2 3 sorry, so 1 2.5 false, true. We can have, for example, another tuple. Okay, so for example 1 7. Okay, so it will create this set type set4. So we have a set, but if we try to have another set, for example set1 equals to, we try to copy that, copy, and we change this to list, so it will generate for us an error. Okay, and also if we change it to set, call it 6. Okay, so call it set, and we change it this one, we'll get also an error. So we can only have a tuple inside set. Okay, so this is about the data types inside the set. For example, as we have created in here, so I will just copy that, copy, paste. Okay, so we call it set1, and we call this set2 equals to, for example, 1 2 and 3. Okay, for example, if we want to add an element inside the set1, so we just can write set1, okay, dot add. For example, we add number 4. Okay, and we have here set1, it will be added anywhere because we don't have an index. Okay, so it will automatically add it to the first element that we have. If we want to try something else, so set1 dot add 5, for example. Okay, and we print set1, it will add it directly to the first element. Okay, as we have seen in the lists, when we use, for example, the append, it will add it, we add to the last element of the list, so the last index. But as you can see in here, it will add it to the first, so it will put it from the left to the right. Okay, and if you want, for example, to add all this set to this set, we can use the update. So we write set1 dot update, sorry, update, and we write set2. Okay, so it will update set2 into set1. Okay, so for example, we can also use the union function. So we create set3 equals to, for example, 4, 5, 6. Okay, and we do set1 dot union, so which means that we add the set3 into set1. Okay, so we have 1 2 3 4 5 5 4 1 3 2. Okay, 5 4 1 3 2 1 2 3, and we have added the 4 5 and 6 into our set1, for example. Now if we want to remove elements, okay, for example, we want to remove I don't know, for example 3. Okay, so we write set1 dot remove, and we write 3. Okay, so if we print set1, it will give us 1 2 3. Oops, sorry, because I had to, normally it would directly work. Wait, set1 dot remove 3, so it does not exist. And when we print set1, okay, so right here set1 equals to, so if you want to print set1, okay, 1 2 3 4 5 6, and so we have removed 3. Now we want to remove, for example, 4. Okay, so set1, it will have 1 2 3 4 5, so 4 5 4 1 1 2, sorry. So we have removed the 4, and we remain by this last set. So this using the remove, and as we have said, set1 dot remove 3. Okay, it will generate for us an error if 3 does not exist. Okay, but we can use the discard. For example, we will remove 1. Okay, so we say that set1 dot discard. Okay, and we write 1. Okay, so 1 is removed, has been removed. But here, if we try to remove 1 again using the discard function, okay, discard, and we write 1, it will not raise an error for us. Okay, so discard and remove do exactly the same thing. Just remove if the element does not exist inside the list, it will create for us an error. Whereas discard, it will not generate an error. So if we replace it by remove, so we'll have an error. Okay, this is the main difference between remove and discard. And we can also use the pop function. Okay, set1 dot pop, and it will remove for us 5. Okay, since we don't have an index for any element inside our set, so pop, it will not, for example, like in a list, it will by default remove the last element of the list. Okay, because we have the index of the last element. But here, as you can see, 5 is not the last element, but it has been removed by the pop. So it will choose any element or any item inside the set, and it will remove it. Okay, because we don't use indices. If you want to, for example, to clear a set, okay, we use set1 dot clear, and here we will get set with no items. Okay, so length of set 1 is 0. And we can also delete using the del function completely the set. So if you call set1, it will say name set1 is not defined. So this is to clear, to remove all the items inside the set and to get an empty set. But the del function, it will directly remove it from your program. So when we try to call that, it will say to you that it is not defined. So for example, if we create my set, get it my set1, for example, equals to let's say 1, 2, 3, 4. Okay, we run that. We call my set2 equals to, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, sorry, 10. Okay, so we can do the intersection. For example, if we want to know the duplicates inside the two lists, so the elements that are present in here and in here, we can use the intersection function. Okay, so we write, for example, my set2 dot intersection my set1. Okay, so we have the intersection between set2 and set1 is 1, 2, 3, 4. Okay, these are the elements that are present in both the sets. But if we use symmetric difference, okay, it will only keep the elements that are not present inside the two lists. Okay, so for example, if we write my set2 dot symmetric difference, okay, symmetric difference my set1, it will give us the elements that are not inside the two lists. So this is mainly union minus the intersection. Okay, so union, it will create 0 to 10 minus the intersection, which is 1, 2, 3, 4. Okay, so it will give us, so symmetric difference will give us the elements that are not present in both sets. Okay, and there is also my set1, for example, set1 dot is subset of my set2, for example, my set2 true. Okay, because my set2 is or contains my set1, so my set1 is a subset of my set2. Okay, dictionaries are used to store data values in key value pairs. It is a collection which is ordered, they are changeable, and they do not allow duplicates. Also, dictionaries can be nested, which means that we can have dictionaries as values inside a dictionary. And at the end of this video, we will have a small application which is finding the number of letters inside the sentence and returning an output as a dictionary which contains as keys the letters and as values the number of letters for each key in the sentence. To start, we can create a dictionary using the curly brackets. So we write dict1 equals to curly brackets. Then you have your keys. For example, we write 1, comma, colon 1. Then we will have a comma. We'll have 2, 2, right? We'll have 3 and 3. Okay, so we don't put a comma at the end of the last element. Okay, so we use the length to find the length of the dictionary. Dict1 will have 3 elements, we have 3 pairs. We can use the type function to know the type of our data structure, which is a dict. We can also create an empty dictionary using curly brackets. We'll have a dictionary, and we can have any data type that we want as values in our dictionary. So for example, we call it dict3, okay, equals to curly brackets, right? And we can put, for example, as key1, okay, key1 equals to float, for example. We put key2, which is a string. We're gonna put Monday. And the third one, for example, we call it key3, which is boolean. And also we can have, for example, key4 as a list, for example. Okay, so we can have any data type that we want inside our dictionary. Okay, and also we said that dictionaries do not allow duplicates. For example, if we create dict4, okay, equals to, let's say, I will always put numbers because it's much simpler. 1 1, okay, 2, for example, 2, and we add another 2 in here. Okay, so 2 2, right? Forgot the comma in here. Run. So once you print that, you see it removes automatically the duplicates. Okay, so it will print for us only one pair. Thus we confirm that they do not allow duplicates. So here, for example, we can change. Okay, for example, if you want to change the second element, so we can put it dict4. Okay, it is called 2. We can change it to, for example, equals to 3. Okay, so we can write dict4 and it changed the value for us. Okay, we can also add elements. Okay, for example, we can put dict4 dot update. Okay, so we can write, for example, curly brackets, your key and your value. Okay, sorry, 3. So write dict4. Okay, so we have 1 2 3. As you can see here, it does not allow duplicates for the keys. Okay, but for the values we can have the same values for all the keys if you want. Okay, so it does not allow duplicates regarding the keys. Okay, we can also add elements using this method. Dict4, for example, we call it 5 directly. Since it does not exist, it will create it directly for us. Okay, so it will add it directly to the dictionary. Okay, so 1 2 3 and 5. Okay, so this is to add elements to our dictionary. For example, if we want to remove, we can use dict4 dot, and you can press tab. It will give you all the methods that you can apply to your dictionary. Okay, so we said we can remove an item, so you write pop and you enter your key. So we want to remove 2. Okay, so if we print dict 4, give us 1 3 5. Okay, so we can use pop, or if we want directly to remove the last element, we can use dict 4 dot, we press tab and it gives us the list. So pop item, it will remove directly the last element. So you see 5. So we have here dict 4, it is 1 3. Okay, now if we want, for example, to clear, or for example we want to copy dict 4 dot copy. Okay, so we call it dict copy. So the copy function will create for us a copy of the dictionary. Okay, so we have the same dictionary. And if we want to clear this dict copy, okay, dict copy dot clear. So write dict copy, give us 0. Okay, we don't have items inside the dictionary since we have used the clear function. Okay, and if we want to delete it, del dict copy. Once we call that, it does not exist. Okay, because we have deleted the dictionary. So we have seen pop to remove an item, pop item to remove the last item, and we have also, you can also use the del function to remove, for example, we want to remove dict 4 3. Okay, so you write dict 4 and you write here 3. So once you print dict 4, we only have 1. Okay, so we have added, we have removed, and we have copied, and also we have deleted our dictionary. Okay, so we add elements dict 4 dot date. So we add, for example, 2, add 3, we add 4, sorry. Okay, so dict 4, we have this dictionary. Now if we want to iterate or to loop over this sequence, we can use 3 methods. Okay, so for example we start from for item in dict 4 dot items. So it will give us all the pairs that are present in our dictionary. Okay, so 1 2 3 4. Okay, so this is one method. The second method, if we want to know the keys. Okay, so for key in dict 4 dot keys, print key. Okay, so this one to know the keys in our dictionary. And this is the last one, which is for value in dict 4 dot values. Okay, print value. Okay, so we have 3 methods to iterate or to loop over the dictionary. You can use the items, and don't forget the parentheses because it is a function. You have the keys and you have the values. Okay, if you forget one of these functions, you can just print tab, press tab, and it gives to you all the so we have values, we have used update, pop item, pop keys items. So copy, clear, we didn't use yet get and from keys and set default. Okay, so we start from get, we write for example 1. So this is 1 is the same as writing dict for give me the value of the key 1. Okay, so it is the same. So it will call and it will give us the value that corresponds to the key 1, which is 1. Okay, and we have also the from keys. Okay, so from keys it uses 2 items. So we have the first item, which is a list or a sequence, okay, something that is iterable, and the second one, which is the value. Okay, for example, if we want to create excuse me just a second, so we create here for example vowels. Okay, list, we created vowels. Okay, so we have A, we have E, we have U, we have I, we have O. Okay, so for example, okay, so this list of vowels, and we want to create a dictionary that says to us that all these letters are vowels. Okay, we put the first element, which is something iterable, which is a list, so we have an iteration. Then we put here the value vowel. Okay, and we call this vowels dict. Okay, right, once you print vowels dict, so we have A is a vowel, E is a vowel, U is a vowel, I is a vowel, O is a vowel. Okay, so the from keys, it will create for us a dictionary from a list or sequence that is iterable by assigning a value to all its elements. Okay, so it will iterate over the sequence. We have A, we have E, we have U, we have I, we have O. Then it will put for all the keys the same value. Okay, so this is from keys, and we have last one, which is dict for dot press tab, which is set default. Okay, set default will give us, for example, you put here key, we have here for example 4. Okay, and you try to change it, you give it 5 for example, run that, it gives us 4. Set default will give us the value of the key if it exists, or if we don't have, for example, we don't have 5, as you can see here, we have 1, 2, 3, 4. We don't have 5. Okay, so we choose dict 5 dot set default. Okay, give it 5 and we add the value of 5. So since 5 does not exist, dict 4, sorry. So since 5 does not exist, it will create this pair inside the dictionary for us. Okay, 1, 2, 3, 4, 5. Okay, so if the key exists, it will return us its value. If the key does not exist as 5, it will create this pair inside the dictionary. Okay, for example, if we try to do that, set default, okay, we have 5 and we change it, for example, to 7. It will return for us 5 because it exists. Okay, so you write dict 4 and we will have 5. Okay, so now we will have an application about dictionaries which is an exercise that gives us an output the number of letters or the letters as keys and the number of letters present in the string as the numbers, so as values. All right, for example, we can call it, this is an example about dictionaries. Okay, so for example, we have T is present 1, twice, 3 times. Okay, so it will give us as a key the T and as value 3. Okay, to do that we have first to create letters, we call it letters dictionary, dict, which is an empty dictionary. Okay, and we will iterate or we will loop over the sequence text, so call it for letter sorry, in text. Okay, so we just have an idea about what is going to be, so we'll count the number of letters in here. Okay, and we'll get an output as a dictionary. So if letter not in, as we have said earlier, letters dot keys will give us the keys of the dictionary. Okay, dot keys, and it is a function. So if it does not exist, the key does not exist, we will create it. So we call it letters dict, and since it is a string, it is a letter, we cannot use the quotes, but we will use the str function to convert it to a string. Okay, str letter, okay, equals to 1. So here we count T does not exist, so we create the key T and we give it the number 1. Okay, else, okay, so we will find the T again, we'll find T again, which is here, but we do already have letters dict and T as a key. So what we are going to do is we are going to increment that by 1. Okay, if it doesn't exist, we create it. If it exists, we add 1. So we run that and we get our dictionary. Okay, letters dict, we give us a dictionary. So we have T is presented 3 times, H once, I 5 times, S 3 times, etc. Okay, so we'll have all the letters that are present in here and the number of times that each letter is presented or is present in the text string. So this is all for Python data structures full course. I hope that you have learned new things. Thanks for watching and don't forget to subscribe for more tutorials.